Hi, class. Yesterday we spoke about the photoelectric effect and how that led Einstein to the idea that light travels as photons, as packets of energy. And we want to relate that idea of photons and packets of energy to the atom. How is that related to atomic structure? But before we do that, we want to take a little bit of a step back and talk about models of the atom, how the atom was thought about throughout history. So we're going to take a step back for a day or two and talk about models of the atom. Then we will relate how these models of the atom uh, link and relate to the idea of photons. Okay, so the first idea about atoms was it goes way back in history to the early Greeks, and one guy, Democritus, uh, described atoms as being indivisible. And the word atom means atomos, or the Greek word for atom, or the Greek word for indivisible or uncuttable is atomos, which is where the word atom comes from. So the early Greeks described material as you could chop it up into smaller and smaller pieces, but eventually you would hit something that is indivisible, that can no longer be broken down. And that is what they called a tomos, or an atom. So the word atom means indivisible. And they thought of the atom as just a solid object like this. They said, once you get down to that smallest size, uh, that's what it is. It's just a small chunk of that material, and it can't be made any smaller. They didn't think that there was other stuff inside of it that it was made of. They just thought it was a solid chunk of material, and that's logical. I think many of us have taken a piece of rock or something and kind of smashed it, and you get small particles. And if you smash it again, you get even smaller particles, and you get these little particles that are almost dust-like. And we would say, "Wow, that's about as small of this material as we can get." And that's really what the Greeks thought of uh, material or matter was made of. It had this smallest possible size that they called the atom, and that atom was just a solid chunk of that material. But then, and that was really the thinking for thousands of years. And so it's really not until here, about 1904, that we discovered that the atom is not a solid chunk. And this gentleman named Thomson, he developed that the idea was made up of electrons, or that the atom was not a solid object. The atom had stuff inside of it, and one of those items was electrons, and that these were kind of scattered throughout the atom in a sort of a soup of positive charges and these negative electrical charges. And so he came up with this model that's called the plum pudding model, which is just there's this smallest chunk of material. This atom really isn't just a solid chunk of material. It has other stuff in it. It has these negatively charged electrons, and it has some other positively charged stuff in it as well. And how did he discover the electrons? Let's just look at a quick video here. And this is kind of the apparatus that he used. Let me see if I can make that bigger. So at this point in history, they were able to shape glass. So they were able to make a tube like this. And a few years earlier, a guy named Volta had created a battery. So they were able to have electrical current flow at this point in time. And what Thomson did was he hooked up just a piece of conductive material to another piece of material and basically put a high voltage on it. When you put a high voltage on a material, it's easier for the electrons to become to get stripped off of that material, to come off of that material. So he put a high voltage on one side and a low voltage on the other side of this tube, and the electrons began to strip off of the material and move across the tube. And so he was able to see these electrons flowing through the tube. So let's just take a look at that for a second. Just mute that out. So you can see he can actually deflect the electrons by using a magnet. And by doing various experiments, he was able to measure the mass of these electrons, and he was able to determine that they had very, very little mass. They did have some mass, which you might think of as weight, but an extremely small amount of mass. So that was a very important experiment that Thomson did. And so by running those experiments and seeing those electrons and so forth, he came up with this model of the atom, which was very, very important. Really just discovering that the atom was not a solid chunk of material was a huge discovery. And he was awarded the Nobel Prize for that discovery. All right, so far we've got for thousands of years we just thought of as atoms as these indivisible chunks of material. Now all of a sudden, about a little over 100 years ago, we discover that the atom has other things inside of it, specifically electrons, and Thomson comes up with this model of there must just be a bunch of electrons in atoms, and we know atoms are neutrally charged, so there must be some positively charged stuff in there as well. And he came up with this kind of pudding model where the electrons and the positively charged stuff, they didn't call them protons yet, but the positively charged stuff was mixed in there. So a few years later, a guy named Rutherford attempted to do an experiment, and he was sending small particles, basically what turns out to be basically radioactive particles, which turn out to be protons. And he is sending these protons through material, and his expectation is because we know these electrons are so super small in terms of their mass, Thomson was able to figure that out. He just expected that these radioactive particles would simply go through the atoms and wouldn't be deflected at all. Let me show you a quick little video on that. So he made an apparatus that looks like, let me send that to full screen. An apparatus that looks like this. So he had a piece of radioactive material that he sends out, and it's supposed to go through this piece of gold foil here. And the expectation was that all these radioactive particles would simply go straight through, all these positively charged particles would simply go straight through this foil. So let's just take a look at that. So, and many of these particles do simply go straight through and hit the other side, but some of them come flying off and get deflected out like this. Not many, maybe 1 in 20,000, but a few get deflected out and go in other directions. And that's the result that was puzzling. And what they concluded from this was that most of those particles go straight through, as you just saw in that video, but some come in and hit something. There's something that causes them to be deflected. Some of them kind of get bent, and some of them actually bounce like that and get deflected. And the conclusion was there must be something that is massive, that has that you can actually run into inside the atom. And they also were able to figure out that must be positively charged. And so the conclusion of that was that the atom, now we're not going to think of the atom anymore as this plum pudding model where there's negatively charged stuff and positively charged stuff just distributed throughout the atom. Now, after this experiment, after the Rutherford experiment, we now have this idea of a nucleus inside of an atom, where we have this small, very tightly packed, all the positively charged material is concentrated together, in a very small, dense nucleus here in the center of the atom, and the electrons are out here around the perimeter of the atom. And so we get this new model, which gets us away from the plum pudding model. We have this new model where we have a small positively charged nucleus with orbiting electrons around it. And so Rutherford, by his experiment, which was also about 100 years ago, Rutherford is credited with discovering the nucleus of an atom. Okay, and just to put it in to give it some scale, what it says down here is if the nucleus were the size of a raisin, the atom would be larger than a sports stadium. So if you took an atom and you made it just bigger and bigger and bigger and bigger, the nucleus would be about the size of a raisin, if you made the entire atom the size of a sports stadium. So you can get a sense that the nucleus is very, very small compared to the overall size of the atom. And so the vast majority of an atom is empty space, and this dense nucleus is very, very small, is a very, very small portion of the atom, which is why most of the particles went straight through and only a small number of them were deflected off in other directions. All right, so that will do it for today. So again, the early thinking was atoms were atomos, indivisible chunks of material. That's the way we thought about it for really thousands of years. Then we discovered the electron as we had techniques as after Volta discovered the battery or invented the battery, we're able to do different types of experiments. And Thomson discovers that atoms aren't just solid chunks of materials, that they've got electrons, and he's credited with the discovery of the electron. And then just a few years later, Rutherford does this gold foil experiment and discovers that the structure of the atom the way we think about atoms needs to be changed. And we now think, after Rutherford's experiment, we now think of the atom as having a small, dense nucleus surrounded by orbiting electrons outside of it. Okay, and then next time we'll talk about, over the next 2 or 3 days, we'll talk about the next evolution in the thinking of the atom and how that relates to the photon. Okay, I'm going to send you a couple of additional videos to take a look at, and then please fill out the form, the Google form. Thank you.